Today's lesson will be on finding distance in the coordinate plane. Earlier in the year, we found distances of points in the first quadrant, so just with our positive numbers. So I'm going to review that here. We have 2 points graphed. We have 4, 10 and 12, 10, and we wanted to know how long is this line in between them. So one strategy for this is that we can just count. So if I count here 1, 2, 3, 4, 5, 6, 7, 8. So we know that this line is 8 units long. Now, that is an okay method to do as long as you can see the graph and you're able to count on it. Where that tends to get a little bit tricky is if we aren't counting by ones and instead we're counting by 2s or 5s or whatever it may be. Oftentimes I find students forget to count by that interval of 2, 3, or 5, whatever it may be. So we actually worked on subtracting the ordered pairs to find the length of this line. So this is a horizontal line, and our horizontal axis is our x-axis. So we're going to look at our x-coordinate in both of these ordered pairs, which would be 4 and 12. Now, what 4 and 12 mean is 4 is telling us that this first point here is 4 away from the y-axis, and this 12 is telling us that this is 12 away from the y-axis. So if all we want is to know the length of this line, we're going to do 12 minus 4. We're going to take this entire line here, this 12 away from the y, and we're going to subtract this 4 away from the y because that's not part of the line we're trying to find. So by subtracting these two, we find that this line is 8 units long. So now let's start to apply that to the coordinate plane and when points might not be in the same quadrant. Okay, so we are going to look at this horizontal line. It is in the coordinate plane, and the 2 points that we've graphed are in different quadrants. So in this problem, since it's horizontal, we are still going to look at their x-coordinate because x-coordinate is our horizontal one. And what this 4 means is that this point is 4 away from the y-axis, and this -2 means that this point is 2 away from the y-axis, excuse me. It's just to the left instead of the right. So the trick here becomes that we don't need to subtract these because we're not taking away any part of that distance. What we're actually doing is we have 2 distances that together make the length of this line. Now, the next tricky part is, okay, so if they're going together, then that would imply that we're going to add them. But one's negative and one's positive, and if we did 4 plus -2, that actually makes 2, like that makes it smaller, and that doesn't make sense. So we are actually going to use our knowledge of absolute values because, as we've talked about kind of throughout this chapter, a negative number is a situation. It's not a true value. We can't have -2 units. What we actually have is we have 2 units to the left, and left is kind of that negative situation. So we're just going to take the absolute value of both of our x-coordinates. So -2, the absolute value of -2, and the absolute value of 4. So the absolute value of -2 is 2, and the absolute value of 4 is 4. And then we're going to add them together, which tells us that this line is 6 units long. So since they were in different quadrants, that's where we decided we're going to add them. Okay, different quadrants, we add them, but we need to add their absolute values because those negatives might throw us off if we just added it as a negative with a positive. Okay, so let's try this again on the next one. This time we are looking at a vertical line. Since this is vertical, we are going to look at their y coordinates this time, okay? So if it's a vertical line, we look at their y coordinates. Another hint, if you're not sure what one to look at, if we looked at their x coordinates for this one, they're both 3 and 3. They're exactly the same, okay? So when they're the same, that's when we kind of ignore them for right now, because the length of this line, since it's vertical, is going to depend on its y coordinates. So 3, 5 tells us that this point is 5 away. Oops, I went a little too far that time, sorry. 5 away from the x-axis. And 3, -3 tells us that this is 3 below the x-axis. So let's take the absolute value of each of our y coordinates. So the absolute value of 5 is 5, and the absolute value of -3 is 3. We add them together because one is in the first quadrant and the other is in the fourth quadrant. If they're different quadrants, we add them. So 5 plus 3 is 8. And what we're essentially seeing here is this 5 is the length of this line here, and this 3 is the length of this line here. We had to use the absolute values because we didn't want to think of that 3 as -3. Okay, distance is always positive, so even though it's down 3, it's still 3 away from the x-axis. Okay, let's review this. Okay, the rules we need to kind of remember for finding lengths in the coordinate plane is that if the ordered pairs are in the same quadrant, you are going to subtract. And so one way I remember that is same and subtract. There's, both start with S's, okay? So if the points are in the same quadrant, you're going to subtract their absolute values, still using those absolute values for subtraction. If the ordered pairs are in different quadrants, we're going to add their absolute values. They don't start with the same letter, but that D in different and then the D's in add, okay, that's kind of the association I make there. So same quadrant, subtract their absolute values. Different quadrants, you add their absolute values. Let's apply this to shapes, not just lines. For this problem, we have rectangle ABCD. So a couple things we'll want to notice is that A and B are in the same quadrant and D and C are in the same quadrant, but A and D are different and B and C are in different quadrants, okay? So let's start by just finding the length and the width of this rectangle. This problem might be one where it says, find the perimeter of this rectangle or find the area. No matter what the question is asking you, the first thing we're going to need to know is what is the length and width. And again, we can always count on these, but I just really want you guys to get familiar with kind of the adding and the subtracting the absolute values. So let's find the length of line AB. So you will often see this as capital A, capital B with that line over it, and that means what is line AB, or what is the length of that? So A and B are in the same quadrant, okay, same quadrant, subtract their absolute values. So let's think about A, okay, so point A, oops, 1 second, so point A is at -4, -2. Point B is at -4, -5. So since this is a vertical line, we're really looking at, okay, B is 5 away from the x-axis and A is 2 away from the x-axis, but we don't want to include that 2 in the length of this line, so we are going to take the absolute value of our y-coordinate in B, so the absolute value of -5. Since they're in the same quadrant, we subtract the absolute value of our y-coordinate here, -2. I know that the absolute value of -5 is 5, and I know that the absolute value of -2 is 2, so 5 minus 2 equals 3. Now, one mistake that's easy to be made is maybe you started off with the absolute value of -2, subtract the absolute value of -5. So that's just kind of writing it backwards. That's why I like to draw these lines here and really think, okay, well, 5 is that longer distance and 2 is the part we don't want, okay? So we know that the length of line AB is 3 units. And we got that by doing the 5 minus 2. So now let's look at the length of, let's say, BC. And you could do AD too. It actually doesn't matter. We know that those lines are going to be equivalent because they are opposite sides of a rectangle. So if we're looking at line BC, which is a horizontal line, so horizontal, we're going to use that x coordinate or the x-axis for this one. So let's look at point C is at 5 comma negative 5. And since this is horizontal, we are looking at the y-axis this time, being that C is 5 away. I'm sorry, I think I accidentally said we're using the y-axis. We're definitely using the x-axis, so I apologize for that. Point C is 5 away from the y-axis. Point B is 4 away from the y-axis. So since they are in different quadrants, we're going to add them. So let's do the absolute value of negative 4, which is the x coordinate for point B. We're going to add different quadrants, add the y, the absolute value of our x coordinate. Lots of x's and y's, guys. I apologize. I know that the absolute value of negative 4 is 4, and the absolute value of 5 is 5. 4 plus 5 is 9. So for rectangle ABCD, we know that it has a length of 3 and a width of 9. Can go back and forth on those. So let's find the perimeter now. Okay, we know that for perimeter, we would add all the sides. So I'm going to do 3 plus 3 plus 9 plus 9. I know 3 and 3 make 6. 9 and 9 make 18. That means we have a perimeter of 24 units. And if we wanted to find the area, we would do our length times width. So 3 times 9 means that we have an area of 27 units squared. All right. So on the next page, we're going to have one more problem. Let's give it a try. So I would like you to go ahead and pause your video. I want you to try to find the length and width of this rectangle, and then from there, find the perimeter and area. I'm going to go over it in a little bit. All right, so starting off, I'm going to find the length of line AB, and you may have done things in a slightly different order, but we can compare. So A and B are in different quadrants. Now they are both on the y-axis here, but they are on opposite sides of the x-axis. So I know that A is at 0, 5, and B is at 0, negative 2, since they are in different quadrants. And another way to know these are in different quadrants or to add them is that one of our numbers is positive and the other is negative. So whenever you have that difference in positive, negative, that's going to be a, find the absolute values and add them situation. So this is a vertical line. I am looking at their y coordinates, 5 and negative 2. So I'm going to do the absolute value of 5 plus the absolute value of negative 2. The absolute value of 5 is 5. The absolute value of negative 2 is 2. 5 plus 2 is 7. So I know the length of line AB is 7. Now let's find the length of, I'm going to do BC. Again, you could have done AD or you could have started with DC. You should get the same results just because these are both rectangles. C is at 5, negative 2. So this is a horizontal line, so we are looking at their their x coordinates. It's very easy to get those mixed up. So x coordinates. So I'm going to do, and these ones are in the same quadrant. Now, B is on our y-axis and C is in quadrant 4, but this would technically be a subtraction. Truly, you could add or subtract these because if we know that 0 is here, what's the absolute value of 0? 0. So I'm going, oops, my eraser. Okay. Hopefully you can notice that, oh, the length of this line would be 5, but just to show you how that works out too, the absolute value of 5, and then you can either add or subtract because it's just going to be the absolute value of 0, which means that 5 minus 0 is 5. The length of BC is 5. So now when we go to find things like the perimeter in the area, so perimeter, we're going to add all the sides. So I'm going to do 5 plus 5 plus 7 plus 7. 5 plus 5 is 10, 7 plus 7 is 14, 10 plus 14 is 24 units. And my area would be 5 times 7, length times width. That makes 35 units squared. Okay, so I'm just going to end this video by going back to our summary page here. When you're finding those lengths in the coordinate plane, if they are in the same quadrant, or they have that same, they're both positive or both negative when you're looking at the x's or the y's, you will subtract them. If they are different quadrants, or one's positive and one's negative, you will add their absolute values.